Welcome to Math 31. This is a lesson on combining rules. So combining rules means that we will have functions that, in order to differentiate them, they will have to involve the product rule and the chain rule, the quotient rule and the chain rule, in whatever order, or also just having to do the chain rule a couple of times. Not a big deal in terms of the the difficulty of it. It's just that you have to be very careful. Very messy questions. So to start off, let's take a look at this one. Y is equal to 2x times x minus 5 cubed. Now, the key to do these ones properly is to have a bit of a game plan and decide what method you're going to use to solve it, because you will eventually have a fair bit of choice. And in this case, to me, this looks pretty clearly like a product rule question. This is my u, this is my v, so I will use the product rule. So I, off to the side, indicate u is equal to 2x, and that v is equal to x minus 5 to the 3. Now some of you might be thinking, well, why do I need to use the product rule when in the previous lesson we had almost the identical question, and we did not. We just ignored we had y is equal to 2 times something. The key is this variable x. If that was just 2 times x minus 5 cubed, we would not have to, we would just use the chain rule and be done with it. But because it's 2x and the derivative of 2x exists as another number, we have to use the product rule. And we could have used the product rule on those previous ones too, but it would have canceled out one of the terms and it wouldn't have been, would have been just extra work. So when you have two or more factors being multiplied together where there are x variables or there's variables involved, you must use product or quotient or whatever else. So u is equal to 2x, so u prime is equal to 2. And the part that's combining rules means that when we take the derivative of v, v prime is equal to 3 times x minus 5 to the 2 times 1. So I had to use the chain rule on that one. So v prime is equal to 3x minus 5 squared. No, not a big deal. It wasn't a difficult question to work out. They will get worse though. So y prime is equal to u prime v plus u v prime. So we just substitute in, and with extreme care. Remember, if you make mistakes with questions like this, there's no real recourse. You can't tell that you lost something along the way. So you have to be very careful. So u prime is 2 times v, which is x minus 5 to the 3, plus u, which is 2x, multiplied by v prime, which is 3 times x minus 5 to the 2. Actually, I probably wouldn't put this bracket there. Just write that as a multiplication. And you could take the time to multiply that 2x by 3, giving you 6x, and that's fine. But I'm not going to, because all I want to do is take out a common factor from each of these clusters. So sort of like we were doing recently, and then also back in pre-calculus days. I look at that and I see a factor of 2 can be divided out, but also I can divide out a common factor of x minus 5 to the 2. And then that would leave me with, in the first cluster, a factor of x minus 5. It's all that's left. In the second cluster, the 2 is divided out. 3 remains, so does an x, and that's it. So y prime is equal to 2 times x minus 5 squared. Get the like terms together, and you'll get 4x minus 5. And that's it. So not a particularly complicated one, but and it will get more complicated, but it does illustrate the basic method that we use for these ones. So I'll go through a number of examples showing, a fair bit of variety. Number 2, f of x is equal to the square root of x plus 2 over the square root of x minus 1. So I will off to the side take a u as being x plus 2 to the 1/2, and v being x minus 1 to the 1/2. And I will note that this is going to be u over v. It's going to be a quotient rule question. So u prime will require the chain rule. It becomes 1/2 times x plus 2 to the negative 1/2 multiplied by 1. I won't bother putting the 1 there. V is equal to 1/2 times x minus 1 to the negative 1/2, also times 1. So we got lucky in that the bracket didn't contain a very complex expression. So y prime is equal to u prime v minus u v prime over v squared. So y prime is equal to 1/2 times x plus 2 to the negative 1/2 multiplied by v, which is x minus 1 to the 1/2 minus u, which is x plus 2 to the 1/2 multiplied by v prime. This should be v prime there. So v prime is times 1/2 x minus 1 to the negative 1/2. All of this is over top of v squared. So something interesting happens on the denominator. X minus 1 to the 1/2 squared becomes x minus 1, just plain x minus 1. So 1/2 raised to the exponent of 2, x to the 1/2 to the raised to the 2 would cancel out the exponent. So we now do what we did previously. We take out a common factor. And when you look at the coefficients, you want to remove a factor of 1/2. That will eliminate the fraction, and that's a good thing. And then with respect to the x plus 2's, we take out x plus 2 to the, always to the lowest exponent, so that's negative 1/2, and then x minus 1 to the negative 1/2. So again, the lowest exponent there. And then that would leave us with x minus 1 to the 1/2. When we divide by x minus 1 to the negative 1/2, we subtract exponents. So I'm not showing this. We've seen it before in pre-calc particularly. But 1/2 minus negative 1/2 is 1/2 plus 1/2 is 1. So we end up with x minus 1 to the exponent of 1. I won't put a bracket around that one because we don't need to. And then the second one, the 1/2 divides out. So does the x minus 1 to the negative 1/2. But we end up with x plus 2 to the 1. And then this is all over x minus 1. When we get the like terms together within that bracket, we'll get, first off, 1/2, the factors will be 1/2 times x plus 2 to the negative 1/2 multiplied by x minus 1 to the negative 1/2. So I'll do this really quickly. This becomes minus x minus 2. So we get x minus x, it goes away on us. We get a break. And then minus 1 minus 2 is minus 3. And then this is all over top of x minus 1. And now we have to deal with the issue of cleaning this one up. And there's a few things that we want to do. Currently we have a complex fraction because we have that 1/2 on top in the numerator. So we're better off, and I'm going to write it now as dy dx, we're better off taking that 1/2. 1/2 on top is the same as having a 2 on the bottom. Now you can deal with that a couple ways. It's 1/2 divided by 1, so 1/2. Or you can multiply top and bottom by 2 to cancel it. Same thing. But this is what you want to do for sure. And then x plus 2 to the negative 1/2, if you take it to the bottom, it becomes x plus 2 square root of. And it isn't necessary to write it as in radical form. You will find that most of the time people do that with square roots in particular because it's a clean, easy way to write it. But it's not wrong to write it as x plus 2 to the 1/2. So on a test, if it showed up that way, I wouldn't take any marks off. And then also in the denominator, x minus 1 comes to the bottom. And then on top, we've got the factor of negative 3. And I'll leave it like that. So it remains. And I think everything else is there except for x minus 1 on the bottom. Let's not forget that. And then that brings us to an interesting position. I was a little premature in putting it in radical form. I just put my head down because when we look at this now, we might see, there's your x plus 2, that we actually can simplify x minus 1s because this is, I'm just going to, off to the, above this, show it. This is x minus 1 to the 1/2 times x minus 1 to the 1. So in fact, that should be combined. And if you add the exponents, this will give you x minus 1 to the 1/2 plus 1. So that's x minus 1 to the 3/2. And then I will write that in radical form just because I have everything else in radical form. It's the square root of x minus 1 raised to the exponent of 3. Now it's not all that common you run into that, but it does happen. So you're always looking for simplification, and that is the rule, the principle behind all of it. Is if it's going to lead to like terms or some sort of cancellation or combining, you do it. If not, you don't have to do it. Problem is, you often don't know that you have to do it, that there'll be a simplification until you've taken the initial steps toward it. So most people err on the side of going a little bit further, trying to simplify. It's not really an error. It's just that sometimes it's not necessary. Let's keep going. They're getting worse, not better. So for this problem, this is an interesting one because we have choice. This is the first one where we really got a lot of choices. Because some people will take this one and take this exponent of 2 to top and bottom. So they would write it as 3x squared minus 5 squared divided by 2x squared plus 7 squared. And that's okay. The other people would use the chain rule first, which is what I'm going to do. So I take this, and I note that dy dx is equal to 2 multiplied by 3x squared minus 5 divided by 2x squared plus 7 to the exponent of 1, but multiplied by the derivative of the inner. So 3x squared minus 5 over 2x squared plus 7. And now we have to use the quotient rule. So for this one, it required, or I chose to do the quotient rule first, the chain rule first, then the quotient rule. So u is equal to 3x squared minus 5. V is equal to 2x squared plus 7. So u prime is equal to 6x. V prime is equal to 4x. And y prime off to the side will be u prime v minus u v prime all over v squared. So y prime is equal to 6x times v, which is 2x squared plus 7. Hope I have room for all this. Minus u times v prime. So v prime is 4x times 3x squared minus 5 all over v squared, which is 2x squared plus 7 to the 2. Now we're going to have to clean that one up, and we're going to have to then distribute the two factors in front. So 6x times 2x squared is 12x to the 3, plus 6x times 7 is 42x, minus 12x to the 3, plus 20x all over top of 2x squared plus 7 to the 2. So y prime is equal to, the 12x squareds go away, and 42x plus 20x is 62x over 2x squared plus 7 to the 2. Now that we've got that, we can replace it into the expression. So dy dx is equal to 2 multiplied by 3x squared minus 5 over 2x squared plus 7 times 62x over 2x squared plus 7 to the 2. And then we look for the final cleanup on this one. And the cleanup, first off, the most obvious simplification would be multiplying that 2 by the 62x, and that would give us 124x. And then we have a factor of 3x squared minus 5 on top. On the denominator, though, easy one to miss, is that there's a factor of 2x squared plus 7 to the 1 times 2x squared plus 7 to the 2. And this is going to give us all together would be 2x squared plus 7 to the 3. And that must be done. You can't leave that as two separate terms. So nasty business. Be very careful with these. Easy to make mistakes, not easy to locate them afterwards. I'm going to do one more, and then I'm going to just pause, and then continue in a second lesson with these. Now here, y is equal to 4x squared minus 2 to the 5 over 7 divided by 9x plus 1. Not a nice looking question, but it does suggest the quotient rule. Pause me, go through this one on your own. If you're up for it, it would be a good idea. 4x squared minus 2 to the 5 over 7, and then v is equal to 9x plus 1. So u prime is equal to 5 over 7 multiplied by 4x squared minus 2. Subtract 7 over 7 and it leaves you with minus 2 over 7 multiplied by the derivative of 4x squared minus 7, which is 8x. So u prime, if you multiply that 5 over 7 times 8, you'll get 40x over 7 times 4x squared minus 2 to the negative 2 over 7. And then v prime, much easier, is equal to 9. So, moving on, we have it set up for the quotient rule. So y prime is equal to u prime v minus u v prime all over v squared. So y prime is equal to 40x over 7 times 4x squared minus 2 to the negative 2 over 7 times v, which is 9x plus 1, minus u times v prime. Well, v prime is 9. I'll put this in front. And then u would be 4x squared minus 2 to the 5 over 7 all over v squared. And v squared is 9x plus 1 to the 2. Now we're in an interesting position with respect to common factors. Not a new one, because we've been here before. But we have to decide what common factors we're going to remove from this expression. Now the The binomial part I don't think will be a big problem. 4x squared minus 2 to the negative 2 over 7. But it might be an issue with the coefficient, like the 40 over the 7. It matters because if we take out the wrong factor, or no factor at all, then we get these fractions within the bracket. And it's not absolutely wrong, but it's not how you like to write your answer, because it's going to have a complex fraction. So you want to get the fractions out. And to do so, you take a look at the numerators. And we did this in pre-calc with the factoring. 40 and 9, there are no common factors, so it would be just a factor of 1. And then the denominator, we have 1 over 7, because that 7's on the bottom, and 1. Take out the smallest number, and it will be the 7. If we're wrong, we'll find out soon, because we'll end up with fractions inside. So I divide 40 over 7, and I'll do it off to the side in case there's any doubt, divided by 1/7 is times 7 over 1. And it worked, right, because it did cancel out that fraction, leaving us with 40x. And then the 4x squared minus 2 is gone, and then we just have 9x plus 1. And then 9 divided by 1/7 is 9 times 7 over 1, so it's become 63. And then that's 4x squared minus 2. And when we go 5 over 7 minus negative 2 over 7, 5 over 7 plus 2 over 7 is 1. And then this is all over top of 9x plus 1 to the 2. Keep it going, and you'll get y prime is equal to 1 over 7. I'll deal with that fraction in the next term. Right now I'm going to deal with, or the next step, I'm going to clean up this bracket. So 40 times 9 is 360 x squared plus 40x minus, now careful with this, so 63 times 4 should be 252 x squared, and then plus 126. Watch your signs very carefully. And this is all over 9x plus 1 to the 2. So far we haven't seen anything that's difficult. We've just had to deal with, kind of messy numbers. So get the like terms together. So 360x squared minus 252 will give you, it looks like 108. And I will have to bring up a new screen for this one, or maybe not. We have to do it just from here. So y prime, I will bring up a new screen. So y prime is equal to 1 over 7 times 4x squared minus 2 to the negative 2 over 7. And then in brackets we'll have 108 x squared, and then you've got just looks like a straight 40x minus 126 all over top of 9x plus 1 to the exponent of 2. See if I left anything back there. There we go. Now, looking at it, you'll see that there's a few things we can do. dy dx. I'm going to take that 7 to the bottom, and then I've also got 9x plus 1 to the 2. That 4x squared minus 2 can come to the bottom. 4x squared minus 2 to the positive 2 over 7. And then on top, 108x squared plus 40x minus 126. Well, it's a quadratic, and you might be inclined to try to factor it, but for sure you can take out a factor of 2, leaving you with 54x squared plus 20x minus 63. That much can be done. Now, if you played around with that, you might figure that you can factor that, but I don't know if it actually does. In fact, I know it does not. So I just want to make sure that's plus 126. It looks like I changed that to a minus 126, so I'll get my signs correct. And there we go. So not nice, but it works. You just have to be really careful as you go through it. So I'm going to stop right there. That's turning into a fairly long lesson, and I will complete this one in the next video. So thank you for your time.